project was simulation of washing machine using PIC16F877A microcontroller. In today's world, many household appliances play a vital role in simplifying our daily tasks and minimizing the physical effort and improving the overall productivity. The technological progress has transformed the washing machines into a smart, energy efficient, and easy to use devices. The washing machine project, that is based on PIC16F877A microcontroller, reflects this innovation with the goal of developing a smart, adaptable, and dependable washing machine system. We started off our internship by getting deeply into C language and embedded C language. We learned that C language is a general purpose, high level programming language, and it is known for its simplicity, efficiency. It is widely used for developing system software, operating systems, and low level programs due to its speed and portability. Next, we learned about embedded C, which is a set of language extensions for C designed to program microcontrollers and embedded systems. It includes special features that provides direct access to hardware registers, input-output ports, and memory locations using specific keywords. They allow writing efficient, real-time hardware interfacing codes to control the devices like sensors, motors, LEDs, and many more. We dive deeply into embedded systems. Now, basically, what is an embedded system? An embedded system is a combination of hardware and software designed to perform a specific task efficiently. They are focused for control, automation, and performance. Unlike the general purpose computers like PCs or smartphones, the embedded systems are very task specific and highly optimized for performance, cost, and size. They require very less or no human intervention. Let's go deeply into the categories of embedded systems. First is standalone embedded system. Those are embedded systems that work by themselves and do not require any host system. They can be divided into slave standalone embedded system and independent standalone embedded system. Now, slave standalone embedded systems are those which blindly follow the instructions given by the user. For example, semi-automatic washing machine. And independent standalone embedded systems are those which can take decisions by its own without human interference. Examples are self-driving cars like Tesla. Then we go into real-time embedded systems. Those are designed to take actions or decisions within a specific amount of time. They are time-bound systems and timings are strictly followed here. They can be divided into hard real-time embedded system, firm real-time embedded system, and soft real-time embedded system. The hard real-time embedded systems are those in which the deadline is very strictly followed, and failing to do so will lead to life loss. For example, airbags and pacemaker. Then we learned about firm real-time embedded systems, which provides property loss if the timing is delayed. For example, a crash landing or a fire alarm in garments. Next was soft real-time embedded systems. They are those in which a small delay is acceptable. For example, DVD players and PCs and so on. Next is network embedded systems. Those are systems in which multiple components and devices are connected together to perform a specific task. Examples are home automation system, Bluetooth-based system, and monitoring system. Next is mobile embedded systems. Those are mobile embedded systems, and examples are mobile and smartwatch. Next is hybrid embedded systems. These are systems in which more than one category are embedded into. That is, many different categories are clubbed together to form the hybrid embedded systems. Examples are robot, Tesla, and so on. Let's go deeply into our project. Our project was microcontroller-based washing machine simulation using PixSimLab. The project purpose is simulating a washing machine using PixSimLab, and it was aiming to replicate real-world washing machine functionality in a virtual environment. The project begins with a comprehensive understanding of the washing machine components, the cycles, and operation parameters like laundry status, fabric type, load size, water level, and all these were identified during the project. The development tools that are required for this project are mentioned below. They are NP-Lab X IDE, which is an integrated development environment, and it is an expandable, highly configurable software program that helps us to configure, develop, and debug embedded designs for most of our microcontrollers and digital signal controllers. Next is XC8 compiler. This is a C compiler for microchip 8-bit PICs. Now both the programs runs on Windows OS and Linux. PixelLab is a programmable IC simulator laboratory. It is a real-time emulate of development boards with integrated NP-LabX debugger. This is the microcontroller that we used during our project. It is PIC16F877A microcontroller. It is a 8-bit microcontroller of PIC Genius by Microchip Technology. The memory involved are program memory, which is 14 KB flash, data memory, which is 368 bytes RAM, and EEPROM, that is electronically erasable ROM, that is 256 bytes. Then we have clock and power, which involves internal oscillator and low power modes. The voltage at which it typically operates is at 5 volts, and it provides development tools like compilers, IDEs, and debugging tools. The components or hardware used for our project are: one is tactile switches. These are switches that are often used as inputs to control the operation of the device or to interact with the user. When a particular button is pressed, the switch turns on, and when it is released, it turns off. Now, an array of tactile switches forms a digital keyboard. In our project, the RB3 is used as switch 4, which is used for navigating between options. RB4 is switch 5, which is used for powering on the washing machine and to resume. The RB5 is used as switch 6, which is stop and pause during the ongoing program. And RB0 is used as a switch to indicate the door status of the washing machine. Next component is CLCD, which is a dot matrix liquid crystal display, and it can interface with 4 or 8-bit microprocessors. It is an alphanumeric LCD display module. That means it can display alphabets and numbers. It consists of 4 rows, and each row can print 16 characters. It works on both 8-bit and 4-bit mode. Then the CLCD in washing machine that we have designed is used for displaying the current status of the machine. The next key component used is keypads. They are used to give the input by the user in binary format. They consist of push button. They can be triggered in 2 different ways. One is level triggered, that is activated when voltage is on high level, and edge triggered, that is activated when level of voltage is suddenly changed. 2 different configurations are used here. They are sourcing circuit and syncing circuit. In sourcing circuit, the 1 is on and 0 is off, and in syncing circuit, 1 is off and 0 is on. The next component is timers. It's nothing but a simple binary counter that can be configured to count clock pulses that are generated internally or externally. Now once it reaches a maximum value, it will roll back to 0 and set up an overflow flag and generates the interrupt if it is enabled. Now PIC16F877A has 3 independent timers which can be used as timer counters or for PWM generation, that is pulse width modulation generation. Now the 3 timers that are present here are timer 0, which is 8-bit timer, timer 1, which is 16-bit timer, and timer 2, which is 8-bit timer again. The next component is interrupts. An interrupt is a communication process which causes the processor to stop its current task and handle the interrupting sources. The sources of interrupts can be external or internal. The interrupt service routine, that is ISR, is a software routine that hardware invokes in response to an interrupt. This ISR examines an interrupt and determines how to handle it, then executes it, and then returns a logical interrupt value. The PIC has only interrupt service routine. The next two components are buzzer and fan. Now buzzer is used in the washing machine program to keep in track of the washing cycle. It activates for 2 seconds when the washing is completed successfully. Next is the fan. The fan in the project is used to represent the working of washing machine. The spin of the motor starts when any washing machine mode is selected and it continues till the end of the washing cycle. The motor stops when it detects that a door is open and starts again when the door is closed. These are the overall components that are required for the project. Next, we look at the block diagram of the project. In the middle, we have the microcontroller, which is PIC16F877A microcontroller. We have various switches that are provided in the left side. Those are power on switch, which is the switch 5. Then switch 6, which is used for pause and stop. Then switch 4, which is used to navigate between the various options that are available. Then switch 1, that is the door status. In the right of the microcontroller, we have the display, which shows the washing functions in the CLCD, that is the LCD that is displayed. Then we have the buzzer and then the fan. Now let's go and look into the project demo. This is the MPLabX IDE, wherein we write the code for the project of washing machine. We click on the file and create a new project, washing machine. The header files that are required for the project are included in the header files folder here, and the source files which are required are included in the source files folder here. This is the main.c program. The header files which are required for this project includes clcd.header file, digital keypad.header file, main.header file, which is a combination of all these. Then timers.header file, washing machine header files. Then in the source files we have clcd.c, digital keypad.c, isr.c, main.c, timers.c, and washing machine function definition.c. This is the main program. Then we have washing machine function definition, which has all the functions that are defined for this project. The code are included here. To run the project, we click on Build Main Project. This shows us that the build is successful and the hex file has been generated for our project. To check on the functioning of the project, we go to the PICSIMLab. This is the PICSIMLab, where we see the output of the code that was written in MPLab. The file option is used to load the hex file that we generated in the MPLab. We have selected PICGenius as our board and PIC16F877A as our microcontroller. The clock frequency that we have used is 20 MHz and the LCD is 16x4. Now let's start with the output of the project. We click on key 5, that is RD4, to power on the washing machine. On clicking it, we get the screen showing it's powering on the washing machine. Now it displays the various options in the washing program. They include options like daily, heavy, delicates, whites, stain wash, eco contents, woolens, bed sheets, rinse plus dry, dry only, wash only, aqua store, and then back to the daily. The RB3 here, or the switch 4, is used to navigate between the options. To click on a particular option, we have to long press the same key. Now we have long pressed heavy option here. On clicking it, we get into the water level. 5 options are there under water level. They include auto, low, medium, high, and max. To select, we are again long pressing the particular water level that we need. I'm clicking on the max here. Now we are given with the two options. One is to start and stop. We press the switch 5 to start the program. On pressing it, it gives the option as heavy and the time for the program. Now there are two options, that is to start and pause. During the function, we see that the fan is rotating here. Let's click on this pause option, that is switch 6. On clicking it, we see that the time has been paused and the fan has stopped rotating. To resume the function, we click on switch 5. We see that it has resumed. To check on the door open, we click on the RPG. Like the door is open and please close. On releasing it, it resumes. We see that the wash function has been changed to rinse here. Now, after the rinse function is completed, it will change to the spin function. We see that the function has been changed. Once the program is completed, the buzzer is turned on for 2 seconds and it displays the message, program completed and remove clothes. Now we get back to the washing program screen. We look into the switch 6 operation, that is to stop the program. We'll again go back by long pressing and clicking any water level that we need. Now let's try with the switch 6 operation. On clicking the switch 6 operation, we go back to the washing program screen. This is the overall demonstration of the project that I developed during my internship. This project successfully demonstrates the design and simulation of a washing machine using a PIC16F877A microcontroller. The key embedded systems that were applied to this project includes controlling the real-time processes using timers and interrupts, an interface of hardware peripherals like keypad, CLCD, buzzer, and fan, and also providing a user-friendly interface with mode selection, water level configuration, and process feedback. This has served as an effective tool for learning and applying concepts in embedded systems. It also has offered an hands-on experience and has complemented theoretical knowledge and provided a foundation for further exploration in the field of